Okay, we're going to talk about two things today, isosceles triangles and equilateral triangles. And we dabbled a little bit in isosceles triangles, but there's a whole bunch more that we can talk about. So, for instance, if this is an isosceles triangle, which it is, let's call it triangle ABC. What can you tell me about it? No. We would assume that, looking at the way I drew it, that would be congruent to that. Okay? Good. By definition, it's an isosceles triangle. Two of the sides have to be equal, and again, the way I drew it, those two sides will be equal. Now, in a problem, if they don't specify which sides are equal, you got to kind of ballpark it. The way they'll express that is a couple different ways. They'll say triangle ABC is isosceles with AB congruent to AC. However, they may also say triangle ABC is isosceles with vertex angle A. Or triangle ABC is isosceles with base BC. All of that is saying the same thing, that those two sides are equal. But we want to do more than just this. So we're going to do some sneaky stuff here. For instance, I'm going to do this. I'm going to add a segment to this triangle, straight down the middle. And I can create that segment any way I like it, and in fact, I'm going to create it to be perpendicular to that bottom. Okay. And let's call this point of intersection D. Now, we're not going to do this every time. I'm just going to do it once, and out of this, we're going to get a whole bunch of new information so that we never have to do this again. This is what's called a proof. I'm going to prove this is true, and then we can use it from that point on. Okay, so I know that that red segment is congruent to itself. What can you tell me about those two triangles now? Marcel?
CD is equal to BD.
Say again?
CD is equal to BD.
We don't know that yet.
No.
No, not yet. We'll get there. What do I know about the two triangles, Patrick?
They're congruent.
Why?
Because you split it in half and half and half.
When I ask when you tell me the triangles are congruent and I ask you why, you've got 5 answers. What are the 5 answer possibilities? What are the 5 ways you prove triangles congruent? You just did an entire worksheet on them. Side, side, side. Side, angle, side. Angle, angle, side. We did side, side there. Angle, side, angle, and then the last one? Hypotenuse, leg. Back to you, Patrick. Which one?
Angle, side, angle.
I only got 2 pairs of angles. Okay. I'm sorry? Hypotenuse leg. Yeah. Okay. Now notice that without the right angle, this is angle, side, side. And angle, side, side doesn't work, but because we have right angles, we have the triangles are congruent. So I know the triangle ADB is congruent to triangle ADC. Forget about the triangle, just look at that congruency statement. We talked about this at the beginning of the chapter. If I have a congruency statement, then I have all kinds of congruent pieces. There's 6 of them, in fact. So Arsalan, now we come back to what you said. You said BD is congruent to CD, correct?
Yeah.
Well, according to this, BD is congruent to DC, so you got it. What else do we know? Go ahead.
AB is congruent to AC.
Got that. Good. What else? Go ahead.
The two angles at A are congruent.
The 2 angles at A are congruent. Very good. This angle and that angle. By the way, can I say angle A congruent to angle A? No, because there's too many angles there. I'd have to be specific. This is what I would do personally is I would put a 1 in here and put a 2 in there and say angle 1 is congruent to angle 2 because I'd like to avoid doing angle BAD and angle CAD. What do you got?
Angle ABD and angle ACD.
Beautiful. Okay. And that's all 6 parts. Now, out of that, what do we need? Well, we need a couple things. But the thing we're going to use most is the idea that these angles are congruent. The base angles are congruent. Okay, and this leads us to something called the isosceles triangle theorem. Isosceles triangle theorem, also known as ITT. Instead of writing out the isosceles triangle theorem, I have a nice little abbreviation, which I think makes a lot more sense, and it says the following. If this is true, then that's true. Lucy, I pay. Does that make sense? We started with an isosceles triangle that has two sides equal because it's isosceles, and if the two sides are equal, then the two base angles are also equal. Okay. So for instance, how big is X? And in fact, I'll give you two problems at the same time. You and your partner figure out how big X and Y are.
No, because it's a 40 degrees. Yeah. Yeah, because the 40 at the bottom is also
Al, how big is X?
35.
Y?
180 minus 110 is 70. And since the two sides are congruent, we divide by 2. You get 30.
Good. How big is Y, Al?
100.
Y?
Because 40 plus 40 is 80. Since
Wait,
the two
40
sides-
plus 40, hold on. Where'd the other 40 come from?
Because the two sides are congruent. And then 180 minus, or yeah, 180 minus 80 is 100.
Okay. Any problems with that? Pretty easy? Good. Then, let's go back to this. We can also do it backwards. So let's suppose we didn't know it was an isosceles triangle. Let's suppose we knew it was a triangle with just two angles congruent. The opposite of that is also true. So it's a reversible theorem, almost a definition. If two sides in a triangle are congruent, then two of the angles are congruent. If two of the angles are congruent, then two of the sides are congruent. It's an interchangeable operation. So notice, in these problems that Al gave us the explanation for, he didn't do anything crazy like drop a segment down the middle of this thing, like I did on the other one, and then split it into two triangles and prove the triangles are congruent and do all that other gunk. He's just got the fact that we can use this theorem to get where we need to go. So this elaborate stuff with the yellow triangle is just an explanation / proof of why that works. Let's take the same idea and extend it into an equilateral triangle. That looks equilateral, right? We've talked about this already, but that's an equilateral triangle. What other kind of triangles is that? It's equiangular, it's isosceles, keep going. Acute. I think that's it, right?
Yeah.
How do we know it's equiangular? So? Okay. And we've kind of operated under the assumption that, well, it's equilateral, so it must be equiangular. They're each 60 degrees. But we really haven't been able to prove that until today. So let's pretend we don't have this chunk of information here. Okay, we'll start with that equilateral triangle just being isosceles. Let's label it CAT. Based on that information, which two angles are congruent?
A and T.
A and T. Good. Any problems there? All right, get rid of this and put the mark down here. Now, with that isosceles triangle, which two angles are congruent? C and T. And now all of a sudden we get a nice little simple proof that gives us that. Equilateral triangles are also equiangular. Equiangular triangles are also equilateral. How big are each of those angles, by the way? 60 degrees. Any problems? Pretty easy? Okay, good. Most of the stuff that we're going to deal with comes from the isosceles triangle because there's not a lot you can do with equilateral triangles. Okay. That's all I got for you. Let me unlock day 6. We'll be good to go. We're looking at a quiz on Friday, by the way. It's up. It's up for day 5. You can turn it in.